Hello, everyone, and welcome to today's webinar on machinery risk assessment. I want to thank you for taking the time and being with us today. My name is Vern Hill, and I'm the President and CEO at Hilco Incorporated. Before we start, let me begin with a quick background on who we are, what Hilco's relationship is to Fortress, the goal for the webinar, and a few housekeeping items. First, Hilco is a manufacturer's representative firm servicing the Southeast region. The limited number of manufacturers we represent are all leading edge automation companies that are considered to be market leaders in their field of expertise. Fortress falls in that category for safety products. Hilco has had the pleasure of representing Fortress for over 10 years. We're very proud and appreciative of our partnership with Fortress Interlocks. In addition, Hilco has 11 outside sales engineers and 4 application engineers strategically located in the territory to offer you local support. Our distribution channel is highly trained, automation focused, and locally based. They are also ready to provide you local service. Today, our goal is to provide you essential information to help you apply safety solutions in your safety applications. Fortress, Hilco, and our distribution channel partners are all here to be of assistance. Now, on to the fun stuff. We will be running a live Q&A at the end of the webinar, as well as a live poll. If you miss anything, don't worry. A recorded version of this webinar will be available. You can access this on-demand recording on both Fortress and Hilco websites and social channels. I'd like now to introduce today's presenter, Eve Edwards. Eve is an amazing machinery safety standard specialist at Fortress Interlocks. She works closely with partners, technical and sales teams to develop safety training programs. So without further ado, Eve, I will turn this over to you.
Thank you very much, Vern, for that introduction. So yeah, I'm gonna hopefully run you through a very kind of brief overview, hopefully, of risk assessment and how it comes up in B11.0 and how that might apply to hopefully some useful things for you guys. If you do have any questions, drop them in the Q&A and we will get to those at the end. Any that we don't manage to get to, if there are too many, we will follow up by email and make sure everyone gets their their questions answered. So yeah, I'm going to run through some stuff on risk assessment and from that B11.0 standard. Yeah, let's go. So one of the questions that I get asked quite a lot is kind of risk assessment and what is the law around machinery safety? And it's a slightly odd one. So OSHA itself has the CFR 25 CFR 1910.212, if anyone's really into their kind of exact things. And that says that you need to have machinery guarding, machine guarding around industrial machines. And it's worth noting while we're on this section that all machines must comply, and you can't just say, oh, but we've had this machine for 30 years and it's never hurt anyone, so I'm sure it's fine. It does apply to all machinery, that law, which is the OSHA kind of standards, regulatory standards. And then there's a bunch of what are called consensus standards, which are written by approved bodies, which kind of are approved by ANSI. And those, the one we're going to look at is going to be B11.0. Another one which has risk assessment requirements in is RIA 15.06. And that is pretty much similar. So it's a very similar process. And as we'll kind of see, the process is the least important part almost. As long as you're doing the right steps, it doesn't matter exactly which process you're following. So RIA or B11, same kind of thing. You've then got things which are going to be interesting on the next step is going to be B11.19 to look at risk reduction measures and B11.26 to look at functional safety. We don't have time to go into those in tons of detail now, but hopefully you can see how those follow on, and we may be doing more webinars and we can have a chat about some of that as well another time. So when do you carry out a risk assessment? Some of you may think you've done a risk assessment before. Some of you may be here because you've never done a risk assessment and you're not sure where to start. And I'm going to say that actually all of you have done a risk assessment, even if you're not driving into the office much these days. You've probably done it once in your life, and you certainly will be driving up to intersections and things fairly frequently. And every time you do that, every time you come to a stop sign or any kind of intersection, you're doing a risk assessment. You're deciding, is it safe for me to go? Is it not? Crossing the road, driving, anything like that. You're doing continuous risk assessments. And that's really important to remember. You already know what you're doing. It's not as difficult as you might think. Another place is, for example, I do a lot of road cycling. When I go cycling, I will wear a helmet because that will reduce the severity of harm that might happen if I were to get in an accident. I'll also wear maybe high vis and lights, especially if I'm going at night. And that's going to reduce the likelihood of that hazard or that accident occurring. So I do something to reduce the severity of harm. I do something to reduce the probability of harm. And I decide that that is an acceptable level of risk, and I go out on my bike. Other people might decide it's too high risk and prefer to stay in on the couch. That's up to you. Different people have different levels of risk and different levels of acceptable risk. And then finally, of course, what we're kind of talking about here is machinery safety, industrial safety in a kind of factory environment or any kind of thing like that. So why is a risk assessment important? Is another good thing to think about. Of course, that first one at the top there, reducing the rate and severity of injuries, makes a lot of sense. Is hopefully why you think that doing a risk assessment is important. You don't want people to get hurt. Great start. However, there's actually a bunch of other reasons if that's not good enough, to get that sign off on some safety equipment. More reasons to do risk assessment. It's great for employee morale, not only kind of showing that people they're cared about, but actually if they are allowed to get involved with the risk assessment process, which is really recommended, getting employees involved, then they're going to feel valued and they're going to be more likely to follow the requirements that come out of it as well, which is a good point to note as well. Increasing the understanding of the hazards of plant operations. Turns out carrying out a risk assessment, people often think is going to make things more cumbersome, more annoying. It's going to be really difficult because you're just putting things in the way and making their lives more difficult. But actually, if a risk assessment is carried out well, you're much more likely to find processes which can be done better, maybe without going into an area, so accessing less frequently, shutting everything down less frequently, and actually increasing productivity. So there's really no reason that putting more safety in would ever reduce productivity. In fact, you can often make it such that it's more safe and more productive, which is obviously a win-win for everyone. And then, of course, kind of the one that's a bit more boring, but maybe more important as well, is staying legal. Although it's not kind of specifically mentioned in the federal regulations that you have to do risk assessment, it does say that you have to assess and reduce risks. So again, it's going down that there's no specific process, but you do have to have done it. Because if you have an inspector come and ask you why you haven't done something, why you have done something, being able to show that documentation is really, really important and will help you reduce any fines that might be coming your way. Key definitions. So an interesting thing about standards is often they're not necessarily the same definitions as in a dictionary. So in this, harm is specifically physical injury to and damage to the health of people. So we're not going to worry about if anything else is broken. It's only if people are in danger. And then risk reduction measures is something that I'll mention quite a few times. People may know this as safeguarding or safeguarding measures, but we don't really like the term safe in standards because nothing is ever inherently safe. And so risk reduction measures is much more accurate, even if it's a bit more of a mouthful, because it is reducing the risk. You may need multiple to reduce it far enough, or it may not reduce it very much, but it is still reducing risk. But it's not necessarily making it safe in inverted commas, whatever safe might mean. And then acceptable risk is when it is at an acceptable level. So another kind of important sort of step is thinking about who's involved. And then again, in standards, there's very specific definitions of who each person is, and this is what B11 uses. So you have individuals, which are affected persons if they're nearby, personnel if they're kind of employed to be near the machine. Those personnel may have different roles. So there's operators doing normal operation, there's maintenance personnel, there could be contractors, there could be cleaning personnel, there could be all different things within that. If they've got some training, then they're qualified. Qualified, it's worth noting, doesn't actually mean they have to have a particular certificate or, you know, a degree, college degree or whatever. It's training, education, experience, whatever is relevant for that role. And then if they've got permission to do something special, they're authorized, and then a supervisor is supervising. So those are just the terms which are going to be used. So who is responsible for risk assessment is another key question which we get asked. Is it the person building the machine? Is it the person using the machine? Is it the company that owns the machine? Who's responsible for that? And in reality, everyone's going to work together, but component supplier is going to be responsible for the components and providing documentation. Machine supplier is responsible for all the components that it puts together. And especially if, for example, they take a component and have to remove some guarding around it to make it into the machine, that's then their problem to make sure that it's still safe. Machine user is then responsible for how it's used, how it's maintained, making sure it's only being used within the limits which were set by a person who designed and built the machine, and then responsible also for training the personnel and making sure that it continues to meet all of the requirements as it goes forward. It's not left into disrepair, or it's not kind of moved. And because if you put something in a corner and then suddenly there's a hazard where it's awkward against the edge of the building or something, the machine builder can't possibly know that. So it's up to the user to make sure that that is considered. And in B11.0, there is, in fact, this little graph, which you don't need to look at every step, but just to kind of show the idea here that you really should be collaborating, especially with kind of non-standard machinery. The supplier and the user should be working together, knowing where it's going, thinking about everything as it goes. Because if you do the risk assessment at the design phase, it's usually a lot cheaper and a lot easier to make sure the appropriate risk reduction measures are used, rather than having to tack them on at the end because you realize you forgot something. So as I say, design phase, not only of the machine, but also of the system and of the kind of where it's going to go in the factory, how it's going to fit together. Risk assessment as early as possible and ongoing is going to save you a lot of time and a lot of money as you go along. So that's kind of the intro to risk assessment. And now we're going to run through the process and actually kind of how you do a risk assessment, what are the important steps. And as I've put there, the choice of specific method or tool is less important than the process itself. So you don't have to follow this exact set of things. A lot of companies have their own things, as long as it covers the same steps at some point, and as long as it is achieving the same end result, it doesn't matter exactly how you go about doing it and which tools you use. I'll show you a couple of the different tools. So this is the kind of flowchart, which we'll run through fairly quickly. I'm not going to spend tons of time on each individual step because I don't think anyone wants to do that right now, and it would take me far too long. But pretty much you decide what you're going to do, identify tasks and hazards, assess risk, reduce risk, assess it again, see if it's acceptable, validate it, and document it. Boom, easy, right? So what do some of these steps mean? So preparing for and setting the limits. You're going to choose a team, which I'll discuss in a little more detail. You're going to set the scope. What does it actually cover? Which machines? How big an area? Is it the whole factory? Is it one specific machine? Is it one machine and all of the bits coming into it? You know, all those different things. Is it for the whole life cycle? Ideally it would be, but is it not? Is it? Who is it covering? Considering all of these things, like what are you actually risk assessing? And that's really important to get your head around, so make sure nothing is missed. And it's also worth noting what you're not risk assessing. So if it's not including the machine next door, make sure that that's obvious as well. So life cycle, as I said, through from design down to decommissioning. So it's not just talking about standard operation, but everything that could possibly happen to this machine, and how's it going to be taken apart and scrapped at the end as well is an important thing to think about. And then those limits, what's it being used for? Are there lots of different products it can make or different materials it can use? Can it be used indoors? Can it be used outdoors? Can it be used with other machines coming in? What energy sources does it need? Are there certain power requirements? All those kind of things need to also be considered when you're deciding how this risk assessment's going to go. So I said I'd talk about more about team, and the team is really, really important, and it's probably one of the early steps, one of the first steps that you're going to have to do when you're thinking about your risk assessment. And as I said right at the start, hopefully someone was listening, that an experienced and knowledgeable worker is actually your most valuable person in this team. Yes, you can bring in external experts. Yes, you can have management. Management's great because it shows that, you know, there's it's being taken seriously, and they're probably more likely to have the checkbook. But the people who work on the machine day in, day out are the most important people to involve. And there are other people you can bring in. If it's a big risk assessment, you're going to probably need a bigger team. If it's just a small risk assessment, it doesn't need to be many people. But a diverse and interested team, people who want to kind of get involved, is really important. So you've got a team, you know what you're covering. So then the kind of first step when you're actually looking at the machine is going to be tasks and hazards. So tasks are things that you do. So, you know, normal operation, all the different things involved in that. Maintenance, routine maintenance, maintenance when something's gone wrong, like unplanned maintenance, fixing jams, whatever. Lots of different tasks that can be thought about. And then hazards, you're going to think about anything that could possibly happen to cause harm while you're carrying out those tasks, and then also when you're not carrying out those tasks. So the tasks you want to think about operation, processes and things like that. So kind of standard stuff, that's probably quite easy. You just go through a day in the life and what has to happen with that machine. Interventions is really important because that's actually where you're going to have a lot of the more dangerous things, because that's going to be things you maybe don't think about, and it's where someone's like, oh, it's just a bit jammed, so I'm going to use a broom handle to poke it out and things like that. That's where you need to be considering. That's really important in your risk assessment. Also minor maintenance, so kind of standard maintenance that's going to be ongoing and doesn't necessarily need a full kind of lockout tag out or a full energy isolation procedure, because any major maintenance, you're going to have its own risk assessment. But for stuff that happens regularly, you want to have it in the main risk assessment, otherwise it's going to cause you issues. And then an important one I've highlighted here is foreseeable misuse. So anything that you could see happening, if it's really easy and looks like great fun to stand on the machine or climb over something or take something apart, if it's foreseeable that someone's going to do it, you need to consider it. And foreseeable misuse actually also includes if someone, if something exploded on the machine and someone jumped, are they going to hurt themselves because they were shocked? If someone touches something because it's hot, are they going to recoil and put their hand in something else? So it's anything that you can foresee happening, even if it's not a task that is maybe meant to be carried out. So hazards, again, you've got to think about kind of everything that could possibly happen, anything that's foreseeable. So from energy sources, different kind of injuries from moving parts, does it give out hazardous gases? Is it going to be wet and you could slip? All different things like that. And again, using people who are actually doing it day in, day out are going to be those people who are most likely to know what those are going to be. So when you do that, you're going to probably take some pictures as well for your documentation. you're going to write a list. And a lot of Excel is a great tool. Just ask the UK government at the moment. So Excel is a great place just to make a list of it. You can put the area, put the mode, put the tasks, put the hazards, and a description of it is useful as well to know kind of what you're talking about, because sometimes they can be similar, but maybe slightly different things. And so that's the first thing you're going to do, come up with all the tasks, the associated hazards, and then realize that some hazards maybe don't have tasks associated with them, things like that. So that's your tasks and hazards. Once you've worked out all of those, then you're going to assess your initial risk. And your initial risk is, so risk in general is severity of harm times probability of occurrence. And as I've said here, it's the highest credible level of severity. So, if you could theoretically sever an artery with a paper cut, you don't need to worry about that. A paper cut is going to be a low severity. Probability of occurrence, again, it's the highest credible level. Like, yes, there is someone who might manage to do something really stupid every single time they come near the machine, but you've got to think about what's actually likely to happen if someone's around the machine. So yeah, you also don't need to include alien invasions or anything like that because they're not foreseeable and they're not credible. But yeah, so that's how you assess your initial risk. And there's a few different ways of doing this. And again, this is a thing where it really doesn't matter the exact process. Different people will have different ones. Consistency is important, and everyone understanding what the different levels mean with your particular method are important. So it could look like a kind of table like this, some kind of matrix, where you have that severity of harm along the top, going from negligible up to catastrophic. And then you could have exposure or occurrence from on the side, frequent through to improbable. And as you can see, if it's negligible and improbable, not very likely to get a paper cut, it's low risk, it's probably fine. Catastrophic and frequent, if every time you walk past the machine, it's going to knock your head off, then that's going to be catastrophic. And kind of anything in between fits on this matrix. You'll see that on this one, they've given what the different risk levels, what the different levels mean. And as I say, it's going to depend on, like a lot of companies, especially big companies, will have their own things. Some that they'll say frequent is it is going to happen 5 times a day, and probable is it's going to happen once a day. And that's going to depend on the place. And it almost doesn't matter as long as you're consistent and you know what you are doing. As long as you can compare things, then it's going to be fine. So another way that it can be is some kind of tree diagram, as it would be here. And again, you're doing exactly the same thing. There's a few different levels of severity, a few different levels of exposure. This one also includes avoidance, probability of avoidance, which just makes it, gives it an extra layer of complexity. But again, it goes from negligible through to very high risk. There's also ways of doing it numerically. So hazard rating number is another way of doing it, where it's got like 5 different parameters that are really specifically defined, and then you multiply them all together and it gives you a number. And so yeah, what I'm trying to say is there's loads of different ways of doing it. And it doesn't matter whatever works best for you and your situation. But what you're going to do is you're going to have a look at this. And for example, so another key point, which I forgot to mention, was that when you're doing your initial risk, you pretend that any existing safeguarding or any existing risk reduction measures aren't there, because that means that you're not going to be biased by assuming that guarding is going to be sufficient or assuming that things are going to work. So you basically mentally remove anything that's already there to assess the initial risk. You can then add it back in and decide if it is sufficient later on. So we're going to look at this destacker, and we're going to look at accessing it from the side. And in your mind, you're going to remove this grey guarding and think about how dangerous it's going to be. And so I'm going to say, because I'm the one talking, so I get to decide, I'm going to say that it's a critical injury that you could get. which is disability in excess of 3 months. I think you could probably break some bones, but it's probably not going to cause death. That's what I'm going to say. And I think it's going to be occasional. So occasional, because if there was no guarding here, it would be quite easy to get caught up in it by accident when you're walking past or accessing the area. So that's going to bring us out to serious, and that's probably going to be a problem. So we've got that serious level of risk. And what we're going to do, we need to reduce that level of risk. So it's too high. And if we remember, risk is severity times probability. So to reduce the risk, you want to either reduce the severity of possible harm, make it hurt you less badly, or reduce the probability of occurrence, make it hurt you less often. You can also reduce probability of occurrence by reducing the need to access the zone, which is another good way of doing that, is to just stop people being in the area is going to reduce the how often that injury is likely to happen. So now we come to my favorite part of the whole risk assessment process, which is the hazard control hierarchy, or the hierarchy of controls. And this is probably the most important thing to take away of how to reduce risk. So that first thing you're going to look at, the first step you should always try and take if you've got a risk you need to reduce, is to get rid of it, design it out. You can eliminate things, you can substitute, use less dangerous materials, use less power, if something's a crushing hazard, make it such that the gap is bigger. So instead of completely crushing your arm, you maybe get a slight bruise, or maybe it doesn't get close enough to touch your arm at all. Put things out of reach, build engines inside things rather than having power transmission on the outside where you can get caught up in it, things like that. So anything that just makes it inherently safer is going to be 1,000,000 times better than anything else, because you will, you can't avoid it, you can't turn off things, you can't forget to do your training, forget to put your hard hat on, it's just safer. So that's always the best thing to do. If you can't do that, the next best thing is engineering controls, which are going to be guards, control functions, devices. So that's loads of different things, basically anything that physically stops a person being able to come into contact with a hazard. So a guard physically stops a person coming into contact with a hazard. An interlock also does, because if they open the door, the machine stops, and so they can't physically get to the machine while it's still dangerous. So removing human intervention. And then the last one is administrative controls, which is a big, broad group of different things. So that's going to be anything that basically requires humans to do what they're told, which is always a terrible idea. So it's always the last option is anything that requires people to do what they're told. So that's putting on PPE, that's putting signs saying, please don't come in this area, it's dangerous. That's doing lockout tagout, because that does still rely on people actually doing what they're told. And anything that's kind of training and saying, please don't go in this area because you will get hurt, because people might forget. So just to kind of show this in a vaguely practical example, if your initial risk of someone, pretend that he is washing a window, he's up a ladder, he's not got any hands on, he's wearing a baseball cap instead of anything else, he's not got any hands on there, no one's holding the ladder, that's really high risk, he could get really badly hurt, and it's pretty likely to happen. So I'd say that's very high risk. The one way of reducing that risk is to get a cherry picker, nice expensive bit of equipment, put a hard hat on. He's much less likely to fall because he's now on a stable platform instead of on a ladder. He's got a hard hat, so maybe the severity of harm is going to be slightly lower if he were to fall. So that's great, but the first thing to consider should have always been to design it out. Keep him on the ground, get rid of that risk completely. Can't fall if you're already on the ground. Well, you can, but you're not going to get as badly hurt as if it's off a ladder. So that's reducing risk. And if we go back to that example we had, as you can see here, what they have done is put some guarding on it. And if you don't need access, then just put some fixed guarding on it. If you do need access, then you'll want to put some interlocks on, and then consider B11.19, which is going to tell you kind of how to make sure that your risk reduction measures meet all of the requirements, which we are not going to have time to go through today. But if you check out our YouTube, we can talk about risk reduction measures all day. And when you've done your risk reduction measures, you then need to work out if someone's going to try and defeat them. And I think Malcolm is going to jump in and speak about this for a little bit.
Yeah, I am. Thanks, Eve, for that. So, yeah, motivation, incentive to defeat is something that's close to my heart. I'm working on a couple of standards committees where we're covering these topics. Now, a few years ago, I visited quite a well-known pet food manufacturer who had a conveyor palletizing system, and they were using some non-contact switches on the doors, and they'd actually managed to tape one part of the switch to the other to be able to run the machine with the door open. And kind of took the operator to a side and said, why are you doing that? And there was a problem with the conveyor in that it was kind of pushing boxes off towards the edge of the conveyor and actually over the side. And the operator was keeping the door open and kicking the boxes back onto the conveyor. And it sort of crossed my mind at that side. At that time, we could solve it in a couple of ways. We could make it harder for him to defeat the interlock by putting maybe a mechanical interlock, an actuated interlock in there so that he couldn't tape things together, or additional RFID, etc., etc. But the real issue was the fact that the conveyor was not operating properly. And I think one of the things with incentive to defeat, the big thing that we see is not enough time is spent getting to root cause. And I think we have another slide on this, just covering some of the things to consider once we're looking at motivation to defeat. And you can see some of the things that, like setup and adjustment modes, modifying tool change, the reason for operators having to go inside, troubleshooting the machine. There is the real opportunity, and Eve talked about this earlier, of making your system way more efficient and effective and productive if we solve those problems and remove the need for the operator to enter that space. I'll make one further comment before handing back to Eve. A few years ago, again, in a steel producing plant, when they were doing the risk assessment on an existing machine, they were upgrading the safety to it. The operators had to enter the safeguarded space to apply oil to a specific point in the machine. And that meant the operator was shutting the machine down, gaining entry, applying the oil, coming out, restarting the machine. They solved what they saw as potentially a hazardous situation for the operator by having a plastic tube going to the point where the oil needed to be applied and then applying the oil from outside the safeguarded space. So they were protecting the operator and they didn't have to shut the machine down, so improved productivity. So I would encourage you, rather than use security fixings on safety devices, get back to the root cause and reduce the need for that interaction between the operator and the machine.
Awesome. Thank you very much, Malcolm. So at this point, we have kind of got through to, we've decided on our risk reduction measures, we've reduced the risk, we've made sure that our risk reduction measures are not going to be defeated or there's no motivation to defeat, and if there is, we've done something about it. What we do then is we take those risk reduction measures and we decide if they're enough, because it may be that there's still too much risk left. So we assess the residual risk once you've included those risk reduction measures. So if we go again back to this, so we've got this fixed guarding in place. I'm saying it's fixed to make my life easier on this slide, but it could be any kind of, it could be movable guarding as well. So we have guarding in place, and the important thing to remember with guarding is it hasn't got rid of that hazard. That hazard is still there, and if you were to get to it, the harm it would cause you is exactly the same. So it's still going to be critical. And that's a really key point, is that guarding and almost any engineering controls are not going to reduce the severity of harm, but what they are going to do is take it from occasional, which we had before, down to improbable, because you can't get there. So if you cannot get to the harm, it's not going to happen. So we're now at a low risk. And then the next decision to make is it acceptable risk? And what we come down to for this is as low as reasonably practicable is generally what you're aiming for, which is not to be considered with LARP, which is live action role play. We are talking about ALARP, as it is often shortened to in standard circles or very cool people. So the first things you want to consider are your regulatory requirements. So that's if there is a type C standard, a specific standard for that type of machine, or if there are specific OSHA requirements that say you have to have this type of guarding, or you have to have this type of risk reduction measure, then you have to put that in. That always has to be there. After that, it's going to be down to the team who are doing the risk assessment. And that's going to mean you've got to think about the culture of the place. If everyone is very highly trained and they're not likely to have any issues, then maybe a higher level of risk is acceptable if they're all aware of it and aware of what to do to avoid harm. However, if there's untrained people or even members of the public are likely to come into contact, then you're going to want that level of risk to be much lower. And basically, you want to get it as low as reasonably possible. And what that means is at some point, it's not going to be worth it anymore. You're going to end up spending huge amounts of money to achieve very, very little risk reduction. So it's putting in as much risk reduction to achieve that acceptable level, but without kind of being ridiculous. So it's a slightly tricky toss-up, and it's important that there is consensus from the team, and you can, if there's any question about it, that's when you want to get in experts and start looking for kind of external people maybe who have experience with that type of machine and knowing what that level is. But yeah, so you always have to meet the specific OSHA requirements and specific standards, but after that, it's going to be up to the team what's acceptable. And then finally, you're going to want to validate and verify. So test that these things actually do what they're expected to, making sure that the testing doesn't expose people to harm. So it's not like you build a bridge and then go, oh, we need to test if it's stable and run and jump in the middle. You want to come up with a way of testing so that if it doesn't work, you're not going to get hurt. And you want to think about, are we doing the right things? Are they being done correctly? And then do those safety functions work? Is everything in place? Is everything working as it's meant to? Validate and verify. And I said that was the final one, but the next one is the most important, is to document it. So as I said, spreadsheets are great. You can put all of the right information in. You want to get hold of all of the information from the supplier, all of the documents that you've produced and thought about, and kind of write down all of your assumptions, all of your reasoning. So especially with that acceptable risk, if you've decided that there's a level of risk which is acceptable, or there are residual risks and you're happy with them, that's fine. But you do have to write that down and say there is still this risk of this, and we are okay with that because X, Y, Z. So yeah, making sure that everything is really well documented in case it ever is needed. And that, I'm afraid I've run ever so slightly over, but I've made it to questions. So if you do have any questions, keep them coming in the Q&A. But Jordan, I think, was going to jump in with asking those.
Yes, we've already had plenty of questions flying in, so please, guys, don't hold back in using the Q&A function to ask Eve and the rest of us whatever you might want. First, we've got quite an easy one. Do you need a qualification to carry out a risk assessment?
That is a great question. And as I said before, there's no specific qualification you need to have for risk assessment. The important thing is to have someone experienced, ideally in risk assessment, but most importantly in the machine that they are looking at. The setup that they're looking at is actually the most important. So experience rather than a specific qualification.
And I just noticed someone's putting their hand up. Please do type the questions in the Q&A so we can read them out loud. We actually have one here, probably for Vern. Vern, kind of a dual question here. First, so let's start with, what other manufacturers does Hilco represent?
Yes, we handle Banner Engineering, Turk, Poles Power Supplies, Larco safety mats, and in some states, Fuji HMIs. So limited number, but all great companies.
Fab. And then actually someone was paying a lot of attention to your first few slides because they're asking why you have application engineers over sales engineers. Obviously you have a mix of both. What is the role of that application engineer?
It's the application engineers are really designed just to give a higher level of support. They're more available to connect with customers. Some of our products, PLCs, things like that, demand a lot of programming. I feel like application engineers who are really focused on that area are probably better apt at supporting our customers who are buying from us. A lot of times with our products, we're selling solutions. So it's a combination of selling, let's say, a Turk PLC with a Fortress Linda system, which we've done. And they can go in and they can combine these products, help customers to that level. So it's just more about technical ability, supporting customers locally. I have 4 of them scattered through Hilco, and that's what they're designed to do.
Awesome. And then we've got a couple more here coming in, which you're welcome to answer if you want, Vern, but they're slightly more risk assessment-y. So maybe, Eve, you could take this one. Where do performance levels fit in to this equation?
I'm hoping that it's just me that's lost Jordan, but I'm pretty sure what he was in the middle of saying was where do performance levels fit into risk assessment? And in that case, the answer is going to be that performance levels actually aren't really part of the risk assessment process. Performance levels come later. So once you've kind of got through all of the steps that I've just talked you through in terms of risk assessment, carrying out that risk assessment, you're going to then want to look at if any of those things are safety functions and safety related parts of a control system. And those safety related parts of a control system, which are going to be things like interlocks, basically anything that's going to involve logic and circuits rather than just physical guarding, they are then going to need required reliability levels, and that's what a performance level is a required reliability. And so that's something we can talk about kind of further offline if you're interested in performance levels and how to know which ones to use. But it's kind of the step after a risk assessment. It's not that first thing. It's not part of that risk assessment.
Awesome. I think that's pretty much it. I mean, there's a few more questions, but we'll probably cover those in by email afterwards. Keep your questions coming in while we just finish off these slides, and we will get back to you by email or even schedule a call with you if that's what you'd like to do. So keep them coming in. And Eve, do you want to take away the next couple of bits?
Yeah, so we are going to actually do a little tiebreaker question. And so just to check if anyone was listening, and we will be giving away a personalized key to maybe the first 1 or 2 people who managed to answer correctly. So if you want to get the chat up and answer in the chat if you think you know the answer, something that we covered about halfway through maybe. So according to hazard control hierarchy, which is the next best risk reduction method after designing out? So you should always design out if you can. And what's the next best thing to use? If anyone can remember what I said there, what kind of controls should be used? It looks like a couple of people were listening, which is always nice. So I'll just leave that there for a couple of seconds while people are looking. And then I think we're going to hand over to Vern to close out for us.
Great. Thank you, everyone. We appreciate you being here. To conclude, both Hilco and Fortress are here to help you. We'd love to hear from you with any questions, thoughts, etc. We are here to serve, so give us a call. Don't forget to follow and connect with us on social. As an FYI, I've got a new website that's going to be populated here probably tomorrow or Monday at the latest. That's going to have a lot more interactive information there for you. So check us out. And, thanks again for joining us today, and we'll see you next time.